Welcome to lesson 76, the MAD absolute deviation, or just MAD for short lesson. In this lesson, we're going to talk about mean and how far away numbers are from that mean. So here are the things I want you to look out for while I'm modeling. First, that I can accurately calculate the mean of a set of numbers, that I can calculate the distance from the mean to each set of numbers. And remember, distance is always a positive value, which is why we calculate the absolute value of those distances between each number. And finally, I can calculate the mean absolute deviation. Pay close attention so that you can model the same steps during your checkpoint. Let's look at our first example with mean absolute deviation. Here's a data set of numbers. I'm going to quickly go through the steps and then I'll model one by hand. Mean absolute deviation just means how far away are all the data points? How much variability is there in the set? And the way we measure that is by finding the average of the distances from the mean. Here's the steps. First, you're going to find the mean of all the numbers. You're going to add them all up and you're going to divide them by your data set. So we find the mean of these sets is 76.571. Then you're going to find the absolute deviation, meaning for every single point, you're going to figure out how far away they are from 76 and 571 thousandths. And because we're talking about distance, it has to be an absolute value. So what I'm doing here is I'm just subtracting all the points from 76 and 571 thousandths. And you see I'm using absolute value. So for the last two, if you did 76.571 minus 80, you would get a -3. But because again, distance has to be positive, we're using the absolute value and getting positive 3.429. Right, so that's the second step. Then the next part is you're going to find the mean deviation, the mean absolute deviation, meaning you're going to take all of those distances, you're going to add them all up. Then you're going to find the average of those numbers and you're going to get a number. So from all this work, the mean absolute deviation is 2.816. This pretty much means that all the data are, and on average, less than 3 away from 76.571. So they're all pretty close together. If they're only 3 away from 76, all your data points are very close. There's very little variability. Hit pause, jot this down, and we're going to go and do the next one by hand. Okay, we're going to calculate the MAD, or mean absolute deviation, for this data set. So again, my first step is to add up all of these numbers together so I can start finding the mean. And when I add all of them up, I get 105. So I'm going to do 105 divided by 7, and I get 15. So this is the mean. Now I'm going to find the distance from the mean. So I'm going to take all of these numbers, I'm going to take the first set of numbers, and I'm going to subtract 15 from them. And remember, this has to be an absolute value, meaning I have to get a positive number. So for here, I'm going to get just a positive 5, 20 minus 5, and let me get the next set of numbers, 19, 12, 10, and 12. So each one I'm just subtracting our average. And notice that because these are absolute, I'm getting all positive numbers. Now, for a visual of what this kind of means, think about it on a number line. If this is 15, I'm literally just checking how far away each point is. Those are the numbers that I'm adding up. So for example, I know that 12 is 3 away from 15. I see that 17 is 2 away from 15. So that's all I'm doing. I'm taking all of these, I'm figuring out the distance from the 15. Hit pause and jot this step down. Now for the third step, I'm going to find the mean of all those distances. So remember, absolute deviation is just a distance. So I'm going to add all of them together. I get 22. And I'm going to divide them by the data set. And I get 3.142. So that's just telling me, by average, that those points are a little over 3 away from our average. So just for, again, some context, if this is my number line, this is our mean, this number is telling us that our points are an average of about 3 away in both directions. So our numbers are pretty close together. It's not a lot of variability since 3 is not a large number. And that's it for our second model. This will take a lot of calculations. Some numbers will have decimals, so absolutely make sure you're keeping your work very neat, particularly when you're adding up data sets to find mean and when you're finding the absolute deviation. That'll be the second place where you want to make sure you're getting only absolute numbers. That's it for today, Math Marvels. I'll see you in the next one. Be well.